this is getting recorded.
Yep.
I'm going to try to be on my best behavior then.
Yay!
All right. Now, to explain what I have been doing, how do you sum up what you've spent 8 months on? It's really a question of I need to know what you want to know. I mean, I've been writing an awful lot of documentation lately, and some of that may be useful in this case. Do you want me to demonstrate how things work?
Yes. So I just like in the perfect world, it's also in the invite, but you know an overview of the technology we're using. Are there anything we should know related to versions or potential upgrades or mismatches with anything that is currently out there? A raw overview just of the file structure in the project. A talk about page definitions, an example of mocking it, how Wamp is in there, an end-to-end example that's showing, the server does something and something ends up on the client. Any gotchas or anything about how to extend this with their own components, React, I guess. An overview of the tests, gotchas, stuff that is nice to know, and so on. But yeah, there is at least that's a suggested list. And if you can share your screen, that would be awesome.
One moment, then. Present desktop. Yes, please present desktop. Yes. Give it a moment, and yes, you should be looking at some source code and, well, actually a preview for a documentation file. Does that look about right? Okay. The way the code is structured, basically everything. Let's start. Let's follow the list there like it's an agenda. Yeah. Technology name dropping. What are we using? We are using React version 15 of a reasonably. I mean, updating it shouldn't be a problem, but updating it to, for example, version 16 may require some looking at. I'm not sure. Depends on what they do with it, of course. This is generally true. Let me see here. If we take a look at how the package JSON works, the primary dependencies for it will be listed in here. And there you can see we use, interestingly, React isn't on here. React isn't on there because it's actually pulled in as a side dependency. That's odd. Anyhow, React version 15, Redux also missing. I am so confused now. This is a bit odd. suffice to say, a current version of Redux. The versions themselves are not fantastically interesting. Really, what we're probably interested in are places where changing those versions may lead to trouble. The one spot I really want to highlight there is this, styled components. It uses a preview release of styled components 2, and this is in order to stabilize some tests. Previously, styled components would have some trouble getting its display names for components to be distinct from each other. Styled components 2 is taking steps to fix that, but the API for it isn't locked down yet. The API we're using for it, I can show you an example here. The with_config function is capable of setting a display name and some other configuration information, but it is not really intended as part of the final public API, so it may be changed. That's sort of the big caveat that I want to make known to you here. Throughout the various places where styled components are used, you'll see this pattern here, where it's sort of with_config, display name, and then a name. And that's basically so that when you pull up your DevTools and you pull up your React DevTools for it, then instead of being all manner of styled divs, you actually get the names that you see in the code. That's pretty much why I began using this. It also means that when writing tests, for example, you will get the expected results when you see here. There's the one. So using these names in your tests will have the expected results. Before I put this into play, any styled component that was a div would be equivalent to any other. So if you have like 3 differently styled divs in your code, and you wrote a test, according to the pattern you see here, there'd be no distinction. You wouldn't be able to tell if you had them ordered the right way before. Now you can. So that's why I made that choice. If you update styled components, you are almost inevitably going to have to change this, but you should be able to simply search for the with_config function, because this is the only thing I use that for. So that's something to keep in mind for if you change styled components version. Otherwise, it's pretty open shut. I've used mostly stable features, nothing fantastically exciting there. Now then, other than that, yeah, it's React, it's Redux, it's Redux Thunk, it's styled components. Those are sort of the high points. There's a few polyfills and whatnot in there to make sure that things work even when they're not otherwise expected to. Like, for example, in IE11, there's polyfills that provide things like promises. But other than that, the dependency list isn't fantastically exciting. So, the file structure overview. The console folder is where the actual results that will be shown to users is found, and it is divided into. I've got some feedback.
Just a quick question. Just the
Yes.
console folder it's located below the composite folder in our
Yes.
website structure, right? Yeah. Okay.
This is the whole. This here is the whole folder, and it is located in website composite console. That's where you'll find it. Generally, if you're working on the code, I would suggest having your if you use a command line, for example, what I typically do is I enter the website directory and work from there, because that's where the package JSON and all of that is located. As you can see, package JSON, JSPM, etc. They're located in that spot. So, raw overview of the console file structure. Access contains ways to access the outside world, basically. The one you're probably going to use most is Wamp Client, which basically provides a way to access Wamp RPCs and subscription topics. It can even register them, though this particular wrapper does not have registering as a capability. It can call RPCs and it can subscribe to topics. To do anything else, you need to add your own code for it.
I have a very quick question. Just try to scroll up in that code view. I'm just wondering if our application, if this application is running below, you can deploy our CMS in a subfolder. So it would be hostname / subfolder name / composite. Just looking at that line, I'm wondering, should we expect that we would need to, has this been tested in running in deeper subfolder, or are you expecting to always be at the root?
It has not.
Okay.
So that would probably require a bit of adaptation.
Yeah, okay. All right, but just move on. So now we know that. Okay, cool.
Yeah. You would basically need to locate the composite folder in some way. JSPM can probably help with that, but that's another matter. What other goodies we have? Request JSON allows you to hit an HTTP endpoint and get JSON back, or to send JSON as part of the a post body to such an endpoint. Currently, the only place it's used is for the log page, and the endpoints for that have been stripped out. So it doesn't actually work and isn't currently in use, but it is there if you need it. And then there is post frame, which, as you can see, is deprecated at start of life. It's basically a way for, if the code is running inside an iframe in the old console, you can use post frame to send a message to the outer outer application and have it respond to that. We currently use that for the component dialog in order to cancel it or to finish it with, the selected component. But that's what happens in there, and as you can see, it is heavily commented and heavily deprecated. Don't use it unless you need it, really, please. Lastly, we have Wamp Test, which sort of mixes and matches a bunch of code. But the main thing it does is it runs up a Wamp client, tests that it can contact a router, and if it can do that, it just sort of says, okay, yep, I'm fine, everything is good. If it cannot, it throws up an error message. That's all it does. One thing I would like to comment on that was visible in the Wamp client code here. It imports a wait for function from the mock server. This is to ensure that any of the mock services that I've put in order to build the various interfaces and have them have some code to work up against and have it sort of act like it's real life, that these endpoints are established before they might be called. That the RPCs exist before they end up called. So properly, the bit of code that should be in a production version of this code is this segment here between these two comments. Keep this and keep this, right? If you strip out the mocks, you should probably also clean up this. But yeah, that's sort of the access systems. Onwards, the components are where all the I don't know, can you guess it? This is where all the React magic happens. Specifically, presentation contains all of the presentation components. So a typical one is field set, for example. Yes?
I have a question. What happens if we have HTTPS protocol? Because I looking that there are HTTP replaced but by WS.
See, this is where I was clever. The secure WebSocket protocol is WSS:.
Okay.
So if it's HTTPS, it replaces HTTP with WS, and you get the right security level. Yes, bask in my awesomeness. Anyhow, it should be taken into consideration. I mean, do check that this works. So far, it looks like it does. We've run it on some secured servers when we've done build tests and so forth. I think, but do check that this works, because it is intended to. For request JSON's case, it again uses the URL class from. Well, it polyfills it, but it is part of the standard, and then it uses the current location, so it should take that into consideration and get the right protocol on there. Now, we were looking at these, yes. So field set. You can see the code starts with a React, some prop types. Those are used at the bottom of the file. Some imports here of various things that are useful to it that it'll need. Then there are some styled components declared with CSS written right in, which may look a little weird if you're not used to it, but just like with JSX, you get used to it and then it's awesome. This particular structure here is how to insert code, insert values from JavaScript in your CSS. In this case, there are some color codes. These come from a file that's here. Basically, it exports an object full of color codes. It's not rocket science. Now let me see, because, yeah. Then onwards here we have the component itself, so to speak, the actual meat of the component, and it's a function. It's a function that takes some properties and outputs a React element. Lastly, here is prop types declaration, which is more or less a declaration of the API of the component. So you can see it takes a label and it takes some fields, and those have these types here. Prop types comes from React itself and has sort of the standard JavaScript types. Immutable prop types is a clever little library that there was a guy who made that provides the immutable types, so that you can also verify when a property needs to be an immutable data type, like a list or a map. But that's sort of the basic. Lastly, it exports everything. That's sort of the basic look of a presentation component. It only gets more complex from here.
Yeah, at one point, will you explain, for instance, field set wrapper? Because that's not a tag I'm familiar with. I'm sure there's a definition in there.
It's defined up here.
Okay.
It's one of the styled components.
Okay.
And field set legend is also one. So basically what you do is the syntax that styled components uses is style.tagname for standard HTML tags. If it's, a standard DOM tag, you can just use that. We have a few cases where we need to format something that already is a component, and that can be done by calling styled as a function on it. Let me just see. I think I have an example of it. Do I? There's not one. Yes. The scroll icon here takes the icon class, which is itself already a component, and styles it with this here. Now this works because icon accepts a class name and uses it sensibly. If it does not, then it won't work. The class name is the magic element here. If your component takes a class name and passes it on to the DOM, this will work. So yeah, this also is an example of a ridiculously complex component. It could probably do with some splitting up, but a lot of it is in the styled components that are used here and nowhere else. And then it uses this to build, well, this actually. That's the result of this code we were just looking at. It also structures the content panel. But the basic structure you can see is pretty much the same. You've got, bunch of imports up at the top. Up here, these are the dependencies that it needs. You've got, in this case, I put together some constants containing the needed sizes and so forth, and timing thing for animations, because it's just easier to handle that way. And a simple function that calculates the height of a list from how many elements are in it. And then later on, I use those to create these styled components. The perspective wrapper is the outermost. Explorer is sort of the whole menu on the side, and so on and so forth. Some of them have a default property, like this one, for example, which is a styled image that I would like to show this particular picture, which means I can just use that as a component now, and it'll magically show the right picture. That's a clever little thing I found that React can do. If you were to, import main logo somewhere else and use it, you'd get the same result. If you just, wrote it like it's written down here. You can see here it's just a singular tag in a very sort of XML-y way. Main label is much the same, because the label is also an image. This is the complex version, so to speak. One pattern you can see in this case, if I am not mistaken, yes, one pattern you see here that wasn't in the data field. Zoom in a little so we actually can see what's going on. Is this here? This line, you can see there is a substitution in the XML that is a function that takes props. It's a very useful pattern in styled components. You take props. You can take one of these, the perspective here, the perspective component. You can give it a set of properties, and it'll render with a style based on that. So if you're rendering the active property, what you have here is a function that then takes the properties of the component, checks, okay, is active set, and if so, then it adds color with the app menu active item active color on it. Otherwise, it gets nothing. So it modifies the color if props.active is true. You can use this for all manner of cool shit. The example I really am most proud of, honestly, is in here. You can see here there is a button style sheet. This is because buttons come in many varieties, so being able to set certain styles on them is very useful. So, for example, if I were to say want a small button that has a minimum width of 42 pixels, I could set the type small, right? But this is just an object, right? It's a simple JavaScript object. And each name on it contains the result of this. This is a string interpolator, a string templator. The CSS one comes with styled, styled components, and uses the same code as the usual styled components that you'll see. If you look down here, you can see that it actually begins with the same character. The sort of I can't remember what it's called, backtick. You see the same thing up here. And then everything inside of that is treated as CSS. And you can use the same sorts of insertions that I've described otherwise. So basically what you end up with is a library of styles. And then when you look at the actual button style, there's a function call here to get styles. Get styles. What does that do? Well, get styles is a function that takes properties. And at this point, I'm thinking you're probably catching on what it does. It checks the button style property, splits it by space, so you'd use it similarly to how you'd use a CSS class name in your HTML. And then for each of them, it fetches the button style sheet for that style name. Now, if any of those are not there, it doesn't matter. A null is completely acceptable. It'll understand how that works. It'll deal correctly with that. So what you've got here is that you can say, well, I need a button that has button style small. And what you'll get is a button that is styled to be only 42 pixels wide. The styles that are in use that you'll probably see most are icon right, which moves the icon on the button over to the right side. Now, there's not a good example right here, but actually, if we were to look in here, you can see the typical button has the icon on the left side. But if I were to edit the page, and then you have this is taking a while, sorry. The save button will have the icon on the right side because it's aligned to, oh no, actually. This is an example. The source button has the icon on the right side. So
A quick question: if you go back to the code,
yeah.
why is this not done by simply putting a class and having styling in? So right now, just applying styles based on a class name is, I guess, that's baked in. What can this do in addition? Like, why is this smarter than a classical class CSS approach?
Well, for an example of that, let me present you with the tab bar class. In order to render a tab, we would like to know, is this the active tab, and what is the index of the tab? Because then we can say, okay, well, this tab needs to be rendered this far along the tab bar, and it needs to either be pushed forward or not. So we can't really create feasibly classes for each index. So what we instead do, let me just see what the line is here. Yeah. It differs between whether it's in the doc or not. And if it is in the doc, then it calculates its left position from props.index times 183 plus a 10 pixel margin. And there you go.
Okay, so in a nutshell, we have access to a lot more information when styling than we would in a classical situation.
Exactly.
Okay, thanks.
And you can make styles that depend on more than one property. You can do all manner of things that are just not feasible to do with classes. This is not to say that classes don't have their uses. I think I have some examples where it is actually used. Now this might as easily have been done with properties, but I didn't change it after figuring out how the whole properties dealio worked. So what you're seeing here is some very similar sort of code to what you might find in your average bit of CSS. This and here is not like in SCSS or less. It doesn't refer to where you are right now. It refers to specifically the component you're working on. As well, you can't nest more than one level, but you shouldn't really need to either. Actually, I did have an example of using media queries in here as well, which that works out of the box more or less, as you can see here. I actually use it to display the little arrows on top and bottom of the Explorer when the screen is too narrow to show the whole thing. And I do that by calculating the Explorer's top height and setting that as the max height for a media query. So because I know what size all of the elements are, I can scale it so that the screen size is taken into consideration in the CSS.
That's clever. Yeah, and you couldn't do that with normal CSS.
It would be hard, at least. And yeah, basically, if you can get to it in JavaScript, you can use it in style components. But I think that should do in terms of talking about the presentation components, and we can move on to look at the containers. Now, the containers have the unenviable job of providing the binding link between the state and the presentation. So what you've typically got is, let me see, what's a good one? Yeah, Connect toolbar is simple enough, but covers most of the functionality. Again, all the imports up at top. That's just a list of your dependencies, as always. You build two functions. You have map state to props, which takes your state object and pulls data out of it and transforms it and whatnot and turns it into a set of properties. In and of itself, that's not fantastically exciting. It's just basically an extractor. To do it, it uses selectors. If you look here, this one is imported from layout selector up here. Okay, well, selectors are found in state selectors here. And if we were to look at, let's just take a look at layout selector, you can see there's a bunch of different functions here that are created via the create selector function from reselect. Now, selector is basically a function that takes a state object and puts out some data from it. It's a little cleverer than that because it's memoized. So if you were to twice in a row call the same function, call the same selector, it would only actually execute once. It would then store the result and give it back to you on the second call. So if you call a selector 50 times in a row, you expect to get the same result, you're going to get the same result, and you're going to get it quickly. It's a small but very useful optimization for this kind of case. But the basic structure of a selector is, I mean, this here is sort of the dead simplest version of a selector. It takes the state object and gives you a part of it. It's also not memoized because it's just a simple function. We don't actually use those for anything but building selectors. So instead, if we want to look at the list of perspectives that are in the layout object of the state, we'll get back to this. Just don't worry too hard about that. Just trust me when I say that there's a list of perspectives in the layout object. What you get here is a selector that takes layout selector from up here and gets it as an input for a function, and then we use the get function from immutable to get the member of it called perspectives, and that's the list of perspectives in it. And then you can build up and out from that to create your selectors. The layout object is deep rather than wide. Most of the objects in the state are going to be wide. They're going to be basically long lists of things that reference each other or reference other things. The layout object is more of sort of a tree because it has perspectives that then contain pages that then contain tabs. Each page keeps track of what tab it's showing. Each perspective keeps track of what page it's showing, and so forth. It made sense to structure that way because of how it's used, basically. But it does mean that the selectors end up nesting quite a lot. I mean, current preview selector, for example, references current tab selector, which references the current tab name selector and the tab selector, which go back to the page selector in both cases. And so on and so forth, all the way up the tree until you get to the layout selector. But because they're memoized, they're only ever slow when you change things. But that's sort of in a nutshell what a selector is. And you basically call a bunch of them and you get out the data that you want, and then you feed it, you give that as the result of the map state to props. Map dispatch to props is how you add functionality. So anytime you want to change something, you need to dispatch an action. Or a thunk, but usually an action. An action is sort of, you tell the state, okay, change this thing. And then the state object, the state store knows how to handle that because there's a reducer that takes care of that whole thing, and that's fine. This one allows you to take the dispatch function that you use to tell the state to perform an action and turn it into functions that you can then pass as properties to your components. In this case, we've got a whole bunch, actually. You've got like the save function, which save values is an action creator. Comes from up here. It's part of, it's in the actions directory, and we'll get back to what it actually does. But suffice to say, it starts the state store going and puts some stuff in motion. And we want that to happen when we fire this function, the save function in the actions object. And that's really what the magic is of map dispatch to props. This all comes together because then we say, okay, well, we have connect toolbar frame here, which calls the React Redux connect function with map state to props, map dispatch to props. This creates what's called a higher order component, which is sort of a function that you can use to modify a component in some way. In this case, you can have it send some properties to the component. And the component we would like to send those properties to is toolbar frame. So you have actually two function calls here. You have the first one with the two functions that creates the higher order component, and then you have a function called that applies that to the actually rendering component. But in the end, what we get is that the output of map state to props and map dispatch to props are merged and then passed on to toolbar frame. If we were to then look at what toolbar frame does with them, you can see there's a bit of adaptation and so forth. It figures out, okay, I have these toolbars, and then yeah, when it goes through each of them and makes sure that the buttons of the toolbar are wired up to the actions that it needs, and so on. It's simple enough. It may take a little bit of sort of looking at it, and there are probably simpler ones in there. There are simpler ones in there than toolbar frame. But now you know where to look at least. I think that'll about cover what there is to say about components. And then we should probably move on to looking at some state instead. Oh, that closed up. Now, the state, you probably want to start looking at reducers. A reducer, first, are you all familiar with the JavaScript reduce function for arrays?
I'm not, but I'm not used to much in JavaScript.
All right. At its root, the reduce function is, you can find it on the array class. So anytime you have an array, it'll be available. And what it does is it takes a function and an initial state, and then it starts with running that function on the first element of the array and the initial state. It takes the result of that as its next state, and then it takes the second element and runs the function with those two, and so forth. So what you've got as the active function of it is basically a function that takes an element and a state and combines them in some way and puts out a new state. That basically sums up what Redux does.
It transforms arrays.
Well, sort of, yeah. It takes an array and sort of step by step transforms it into a single thing based on whatever your function does.
It's like sum of all numbers, for example, is simple example would be.
Sum of all numbers, yeah. For example, what that would be is the reducer in that case would be the function that takes your current element and adds it to your current sum, and then sends that on in the process, returns the result. And what you then get is that it just goes through the array and adds all the numbers up, and there you go. In Redux, a state is a data object. It can be any kind of data object. In our case, I have picked an immutable data object. Immutable itself is this page is your friend. Get to know it, learn to love it. The whole trick of immutable data is that if you start with your average object, right, your average JavaScript object, you have that, you say const name equals begin object, whatever inside it, and close object. You can still change what's inside the object. And if you were to have some sort of equality check of two objects, what it does is it actually compares the data pointers. So you can't really use that very easily to compare the data contents of two objects. If you've got two objects that are, in terms of their content, completely the same, but they're not the same object, as in they don't actually reside in the same spot in the memory, they're not equal to each other. And getting them compared usefully to each other is tricky. As well, if you have this one object that you then change, you might not have the result that you expect when you use it later on. Let's say you pass it to a function, for example, this object containing data. The object changes something in there. After calling that function, the side effect is going to be that your object is changed. It doesn't tell you that it has done this, but it does it. This is really impractical sometimes. So immutable breaks that. An immutable object, anytime you perform an operation on it that changes its contents, you get a new object back. And that's your new data object. And if they're content unequal, then they are not equal. They're different from one another when you compare them. And this is true even if you use the triple equals. They are not going to be the same. So you can actually rely on those. I use this set of data classes very, very extensively because of this. Because the whole thing is based on functional programming, on being able to trust that your data doesn't change identity without you knowing. And immutable gives me that. It allows you to do that. So, returning to the state reducer here, what's the simplest one I've got? Yeah, that's probably this one. Activity is, it doesn't actually declare any actions of its own. I'll get back to what actions are later. It's just a reducer that sort of checks other actions that come through. So what you have is you have a state and you have an action. A state. And now this isn't the best example. Sorry, give me a moment. Yeah, let's start with data fields. Data fields is how you store data that is in a form of some kind. So let's say you have a page that has some entry fields on it, and you've typed some things in, and you've selected some things, you checked some boxes, whatnot. This is where it would be stored, and these are the actions they would use to store them with. it starts out declaring some action names here, like update value, which is basically, it's a string. It's a good idea to have these strings have, be recognizable. So I've defined a prefix that they all start with, and then they all have a name on top of that. And then there's a function called update field value, which you can call with a page name, a field name, and a new value. And that then creates an object of the right format that is an action. This is what an action is. It's an object containing some information about, state, do something. The others are completely the same pattern. As you can see, they do different things. And then there's the reducer. It'll be the default export from this this sort of file. Should always be the reducer. You've got a function that takes a state and an action. The initial state here is the default argument, so to begin with, it'll probably get called with nothing in the state as the very first sort of thing. And then it'll use the initial state object as its starting point. The initial state object is a map containing committed pages, which is another map. And that's it. It's sort of the base structure of your data for this reducer. This is going to be placed under I think it's under the data field's name in the state. So the state itself is sort of an array of reducers that it uses. That is added in store.js. And you can see here, reducers starts out as an object containing a number of these functions. They're all imported up here. Then the definition reducer is a little bit special because I have a function that creates a reducer based on a name. So I have a list of names of things that should be created definition reducers for. And those are then added to reducers. And then it creates a store with them. Just feeds console reducers into create store. A lot of the surrounding stuff here is for hot reloading. This is largely irrelevant if it works, and most of it is just a question of using the right incantations, so it's not that interesting really. If it breaks, then maybe, but it shouldn't. But yeah, back to our reducer here. So what you've got in here is a fairly typical pattern where it switches by the action type. And in this case, let's say we have an update value. Then it says return state with mutations. Now, with mutations means, okay, I am going to do some changes on this state object, and I don't really want you to create a new state object for every single change I make. I'm not interested in that. I just want the whole thing in one go. So you can save a little bit on that if you need to make several changes at once. But it takes a function that is that has the state object as a parameter, and then you can make changes as if state is mutable. So you can say, like this says, state.setIn, which does what it says on the box. It sets a value in a particular location, and state it'll build up those changes without you needing to reassign it all the time. You don't need to say state equals state.set something like you would outside of the with mutations function. That's the only place where that works. If you're not inside of with mutations, or if you're using another immutable object inside of there, let's say, for example, I took like the result of state get in committed pages action page name, which is the committed version of a page of data fields. If I were to assign that to an object and then change something or other, that wouldn't work. Not in here. Because the rules for all other immutable objects are still in operation. So that's something to keep in mind when using with mutations. But otherwise, basically, you build up some changes and you return the result. The other example, so to speak, is when you have commit page here, it basically says, well, state a simple set operation of something that it takes the page that you have active right now and saves it, so copies it to committed pages, so that that's the identity of the page as committed. But yeah, the basic structure is that you get a function in, you have a function that takes the state and an action, and then does something based on the action that it gets in, and then returns out a state again. That it, as a default, returns the state itself is critical, because otherwise you're going to get a data wipe. Basically, what you will have then done is, if this state does not have, if it does not have an action that it recognizes, it'll just throw everything out. So generally, when I code reducers, the first thing I do is put in the default case.
Just a quick question: is the
Yes?
reason you're not reacting and like kind of throwing an exception if you do not know what action is requested for? Is that because this is like going across different types of states, so some states may not need to react to it? Like
Every action gets called, gets into every reducer. There's no distinction there. Basically, what it does is it has sort of a list of reducers, and it calls all of them.
Okay.
With the part of the state that they have in hand, and of course the action in question.
So it is actually expected that you could be called with actions that you're not aware of, and there you shouldn't
Absolutely.
do anything. Yeah. Okay, cool.
That's the usual case, in fact, because in any sizable operation, you're going to have quite a number of reducers, and thus also quite a number of actions, and not all of those actions are going to be relevant to you. But this basically is what a reducer is and does. It is that simple. Don't be confused by the simplicity of it. It is that simple, and it is stepwise. In fact, expect Redux to complain to high heaven if you actually manage to mutate the state rather than return a new state object. It should either return the same state object unchanged, so state here, or it should return a new object that contains the changes that you want. All right. That's reducers. The actions folder is kind of misnamed. In principle, it should be like thunks, because that's what's in there. Thunks are, well, I actually wrote about that. Let me just see here. Yes. A thunk is a subroutine that is created often automatically to assist a call to another subroutine, as defined by Wikipedia. There's another, Marcus just threw up a link to another explanation of it. But basically what a thunk is in our terms is it's a bit of code that runs, that can fire assertions, again, not assertions, actions. It can fire actions, and it runs potentially asynchronously. Let me see. Yeah. Values is a reasonably simple one. It actually contains two different thunks, the load values and save values thunk. It defines some actions, some action types, not action creators, because these are typically used in a very simple sort of way, so they don't really need action creators. But you can see it defines a load values done, and a load values failed action type. Now, if we then look at load values here, it takes a page name, which is the page that it's saving, or is loading the values for, and then it returns a function that takes dispatch as a parameter. Now, because we have Redux thunk in the mix, Redux knows that, oh, I got a function back. Okay, I am going to call this with dispatch and getState as parameters. Now, we only need dispatch here because we don't need to access the state. We just need to load some data, fire some actions. That's all. That's the usual case. But what we then do is start by dispatching the load values action with the page name. That's when we grab a hold of the Wamp client and call the value load endpoint URI, which is an RPC. That's an RPC that is defined on the Wamp endpoint there, or is supposed to be anyway. I think I have it as a mock in this version of the code, but it should obviously actually talk to the server to save value, to load values from it, or save values to it, or whatever it is supposed to do, right? But basically what it does there is it hits a Wamp call, and this is of course asynchronous because that's network activity. You're not getting around that. But what that then does is it returns a promise. Anyone here unfamiliar with what a promise is? Okay, I'm going ahead on the assumption that we all know promises. So, two outcomes. If the promise succeeds, it calls the then function, which takes the data that comes in from the return of it, and then it calls the store it calls the store values action creator, which does what it says. It takes some values and stores them. That creates an action for that and dispatches it. So this means that now we have the load values action there first got dispatched. Then we had the store values action got dispatched. And lastly, it says, okay, I'm done now. So now we have three actions in series in our system. Now, if, like me, you have the Redux DevTools installed, it's a Chrome browser extension. I think it's available for Firefox also. Then it is being a bit odd. Allow me to just reload the page. Because then I can show you what this series of actions actually will look like in the DevTools. If you're going to work with this system, get the React and Redux DevTools. Do, because they are fantastic and they will make your experience so much better. Why is my phone suddenly ringing? Yeah, that's going to have to be some other time. Right. Now you can see here, suddenly there's this whole list of things here. In it, perspectives load commence. That looks familiar. Looking at here, it starts with it ends with commence. So there's a thunk there that's doing something. It's probably the thunk that loads perspectives, right? It has a number of things that it then stores, which are definitions, perspective definitions in this case. And then lastly, there's the done function here. So that's how it looks like in the real world when a thunk runs in the Redux store, right? You get this series of actions that starts with the OK go and ends with done. Or if something goes wrong, we end up down here, catch error, and then it throws this failed. In the cases where you get this sort of thunk, it might be worth it to uncomment the line below, because then you get the error output in the console. Now that's really annoying in most other cases, so it's commented out. Another thing you can do is if you go into the DevTools and you click action, then in most cases a fail action will actually contain like the message and the stack trace for the error. So if you just want to look at what's going on, go into the actions view of that action, and you will be able to get at least an overview of the information. But yeah, that in a nutshell is what a thunk does. A thunk doesn't actually have to fire actions of its own. It can actually reference other thunks instead. Load and open does that. It has load and open page. Now you can see there's no actions that it defines itself, but it calls a bunch of functions and sends it to dispatch. This is perfectly allowable. It's perfectly all right. So you can actually make a thunk that dispatches a bunch of other thunks in among actions and so on and so forth, and you can use that to marshal your entire system with. That's largely what this does. It says load and open page. Well, that's a somewhat complex procedure. You need to first figure out which page to get at. Then you need to get that data from the server. Then you need to actually put that data in the state, and then you need to switch to the page so that you can look at it. And it does all of that step by step. It's one of the more complex bits of code in the system. So it's probably not the first thing to look at, but it does make sense, I swear. All right. I think that about covers thunks from sort of a helicopter perspective. Did we need to talk more about selectors, or did you catch that when I touched upon them on containers?
I'm good. If anyone needs info, but I'm not going to maintain it. Tars, the most important, I think, is you and in a second, since you're the most JavaScript knowledgeable. If you feel a need to get a deeper introduction, say so. Not sure. Sure what? You're not sure, or? Should we dive into it?
Sorry?
Should we look more at it?
Look more about what?
Selectors.
Selectors.
Let's look at selectors.
Yeah.
Okay.
All right. Your basic garden variety selector is a function that takes state and outputs some data or other from the state in a form that is useful to you. I think page tree selector is probably reasonable to look at. We have like you know, if we're looking at this page here, you can see there's a little tree of nodes here. This is stored in the state. Let me just show you what that looks like in the state here, like that. That's what it looks like. Each node is just sort of in there in a map that maps them name to node, and then they have a list of children which are names. This, you know, how do you get that into a sensible tree structure, which would make sense if you're you know, actually rendering this stuff, right? You'd want to say, okay, well, render this node and its children and their grandchildren and so on and so forth. This is where a selector comes in. So we start with just a simple function that gives us the page tree part of the state, because that's what we're interested in. That's where all the nodes are. Then let's skip get node and loaded children for now. We get back to that. Current tree selector says, okay, well, I'm looking at this particular tree now, and I would like the nodes involved. Well, each tree has a root node. That root node is stored in the tab that has the browser that is that browser, you know. So what you have here is it references tab selector, which it fetches from this file, which gives you the definition of the tab in question. From that, we need the root node information, which will be the name of the node that we're looking for. So that gives you, you know, the place to start. And then from the nodes list, you extract that. You get the node that fits this name. All right. Now we check, did we actually get something? Because in immutable, if you get something that's not actually there, you get null. This is always worth checking for if there is the least uncertainty that that might be the case. Also, keep in mind the state is loaded gradually, so what is looked for may not be there yet, but may be there in a minute, and you'll be fine if you just say, okay, well, that's not there. But you won't be fine if you try to call a function on it. But basically what it does is it sets the children of the root node to this pattern here, set and then get on the same as a parameter, is a way to modify an element of immutable, right? In this case, we want to map it with a particular function. Node name to get node and loaded children, which takes a node name and a list of nodes. Looking at the function, what we can see it does is it tries to get the node if the node is there, and it has the children loaded flag, and it actually has children, and it has the open flag, which is when we're interested in its children at all. Then it sets the children array to instead contain a map of that of those nodes and their loaded children. So this is a recursive function that basically just goes down through the tree and loads all the visible children of a node. Typically you'll only, I mean, the function that opens a tree node makes sure that the children are loaded before opening it. But yeah, that recurses down through the tree, and there you go, you win, you have a tree loaded, right? So the current tree selector takes the state and gives you the tree of nodes that you're looking at right now, basically. There are another couple here where this one finds what node you have selected and then extracts the actions list from that. And this one basically turns that into a form that is useful for creating a toolbar. So it's a slight modification on it, right? So all in all, what we have here is a set of functions that, from the state, can transform the information in a way that is then useful. So, I mean, that's really it. And because they only take the state as an argument, because they cannot actually change the state, they're completely safe. The worst they can do is throw an error. They can't modify your state in any way, and that's also why, for example, letting packages use their own selectors, let's say, is perfectly okay. That's not going to be controversial at all. Are there any doubts left about selectors?
I'm sure if there are, it will be fixed by a hands-on experience. Let's move on.
Undoubtedly. All right. Now, the last interesting parts of the state system are out here in sort of the state directory itself. We can take them as they're listed. The action locator is kind of experimental at its current point. Basically what it is a set of functions that allows you to register a function with a name and extract a function by a name. So let's say you have this really cool function that, I don't know, shows or hides your it does this, right? That, right? You've made a function that when called with a page name, it does this. Or maybe it doesn't even need to be called with a page name. It just manages that for you, right? So you'd like to call that function. But when you're dealing with, I mean, I've not shown you the way that actions are typically defined, but it isn't where you can put code in. It comes in as a JSON object. That's what'll tell you what code you should run for a button, for example. So what you'll want to do is you want to extract that name. That's what the action locator is useful. So you register that action with some sort of well-formed name that makes sense to whoever needs it. And then at a later point, well, there's an action called useProvider. Now, useProvider, really the test is actually more interesting to look at than the thing itself. Because the test actually documents what a provider is and how to use it. Now, of course, my theme on Atom here means that comments aren't very easily readable. But if you're ever in doubt about what a provider is, this is where you can find an answer. Because useProvider is the thunk that you give an action, a provider to, and then it does stuff based on that. So whatever useProvider says that a provider is what it is. But the central core of it is that if a provider has a call action field, it's basically a data object that tells you stuff. So if it has a call action field, that name, it'll extract from the action locator. It'll get that function from the action locator and call it. So that's sort of the secret of it. And part of the idea was also to explore possibilities for packages, because any package would be able to then register a function with this action locator. You could also expand that to being able to register reducers, or for that matter, you could register page as a component types. There's if we take a quick look at the components, some of the containers, like for example, connect doc tab here. Oh wait, this doc panel I was after. That one establishes panel types because it uses switch panel. Switch panel basically says, okay, well, you give me a list of types of component, and you give me a name of a type of component, and I will render that component for you. So it's a way to make it data-driven what you're actually rendering at any given point. I mean, in this case, you've got an explorer, you've got a toolbar frame. You can render a sprite sheet, a dialog, because we've shimmed it in so that dialogues can be rendered as pages. And a search page is also an option. Because of this, I mean, the Connect tab panel has a similar structure. Because of this pattern, you'd also be able to register component types in a similar sort of fashion. Imagine if instead of just a static object here, you had a registry somewhere that you would then pull these types from. Imagine the same for reducers. It's entirely feasible. And that's sort of what the action locator is the pattern for. Now, it is an exceedingly simple piece of code, as you can see. I mean, it literally doesn't check anything. It doesn't do anything interesting. It just sort of has a library that's an object, and then you can save things on there by name. That's it. It doesn't check if there's already a function like that there. It probably should. It doesn't check that what you're giving it is actually a function. It probably should. And so on and so forth. There's room for a lot of improvement here, but like I said, it is basically a prototype at this point. In its state, well, I'm willing to take guesses on what that does. It takes care of making sure to run up the state to its initial point, to where you can start actually using the application. Now, we have two cases here that we deal with, because there is sort of there's this view here that I've shown you that I've been working on, which is sort of the overall console replacement. And then there are the various views that we use for stop helping. We use for inserting in the existing UI. So, for example, this is a demo page of how tabs work. Once it loads, it takes a little moment because it's the dev version, it's slow. But as you have probably seen, the production version, once bundled and compiled and all that, is quite quick. But yeah, as you can see now, all the Explorer stuff is gone. It just renders that one page. And yes, the tabs work. Anyhow, all of that magic happens in here. And it basically distinguishes on, okay, is there a page ID field in the search parameters, the get parameters on the URL? If there is, yay, we show that page. If not, it starts with loading in the perspectives list, then checks out what is the current perspective, which is part of the initial state, and then it opens the root page for that perspective. And the end result then is, well, what we saw before. Because in this case, the root page is the browser for the content perspective.
Gert, can we run through like an end-to-end sample with the page definition and some state going back and forth? That could be the components, for instance.
Sure. Let me just pull up the page then. So the components page. Now, in the production version, this comes from the servers. In my case, here it comes from the mock services. We haven't talked about them. They're not really that interesting. They're basically functions that just feed out data. But in this case, the page mock function contains sort of a whole bunch of information about different types of pages that you might care to show. And this includes the component selector shim page. That's the one we're interested in. This is what the data would look like coming out of the server as JSON. This is in a JavaScript object format, but if you were to JSON serialize this, that's what you'd want the server to feed out. So what you've got here is you have a name. Basically everything should have a name, because that's how the system keeps them distinct from each other and doesn't overwrite them. So I had it throw up some bugs on me when some things that I finally wired up correctly ended up thrashing each other because I'd forgotten to give them names. So always make sure that there's a name, and it has the type that I showed you the whole switch panel thing before, where there was a list of types of different components that would render different page types. That's where it comes from. So this is sort of your basic page. It also contains a dialog. Now, in this case, because it basically is going to show a dialog, and that's the only thing it shows, that's all that'll be there. Other types of page contain like a list of toolbars and a list of tabs, or some other configuration of data. The dialog then is, again, named. It has an update data provider, which it uses to sort of update its own state with. Now, in order to do this, there's the set dialog state function registered on the action locator, and we wanted to send data as well, because when we update the state, we're expecting to send some data to update it with. But basically what this does is when you like select an item or type in the filter field or something, that's the function that gets called with the changed state to update the display. And apart from that, it has some panes, and that's all it's got. The pane, because there's only one in this case. Potentially you could have more. The possibility for that is absolutely real. And again, name, type, a headline, some various texts. I mean, typically texts that you need to use on a page should probably be in the page definition, because the server is the authority on localizing texts. It knows what text to send along, so that's what you should have in the page definition. A bunch of various information for the actual dialog pane itself, like a filtered categories, and then a list of providers. Now those providers, this is because we use what's called normalization. So what it does is it looks for certain fields, and then it takes the data from that field and puts it in a map based on its name. We want that to happen with providers, but we don't want to say, okay, well, go in and every single type of palette, type of dialog pane, for example, should have this, and this provider. That's really annoying. So in order to try and avoid that, we have a single array of providers, and then we have, in this case, we have some named references to those providers that then get used for whatever their purpose is. And then there are some buttons which will be shown at the bottom of it, which also each have a provider. Now these might easily, again, be similar to this one up here with just a call action and not actually hitting any sort of remote thing. Or they might have a protocol field, which means that they're going to be remote actions, that the provider has some sort of outside effect. So this provider then gets called when the button's pressed. In this case, you can see the post protocol refers to posting a message to the application outside the frame. If you recall back to when we were talking about the access code, there was a way to do that. That's how you do that in this case. And it has some information for how best to do that. Like it should send a response accept, and it should send it should perform an action response action. It should send data along. This field is kind of misnamed. It's misnamed because it was used for the markup to send back when you're selecting a component. Really what it should be is it's sort of a data path. It's sort of, okay, so the dialog data, you don't want to send the whole thing back. You just want to send the one part that you actually need, right? This is where you define that. The array there can be thought of as sort of a dotted list of names. So if you have your data object and you want foo bar baz, then you'd have an array of those names. It'll make a lot more sense once you have studied the immutable get-in, set-in functions, because they use that pattern, and that's what it's based on. So basically, think of it like a path. In this case, it's just the selected data child of the dialog data. That's all. But yeah, that's what the definition looks like coming out of the server. Given that it's a rather critical part of the whole affair, I should probably introduce you to the definitions reducer. Deceptively simple, isn't it? We basically have a list of different types of definitions. There's pages, there's tabs, there's perspectives, there's this, that, and the other thing, right? All of these have a definition reducer connected to them so that you can store definitions of them. You can also overwrite them. This is how you change a page, for example. If you want to update a particular page to render something else, you can change the content of it by storing a new definition. But basically what it does is it takes the definitions that it is given and stores them in the state. Now, there is a thunk that loads page definitions. There's also one for perspectives. But the upshot here is there is a call here to normalize. We haven't looked at that, have we? Normalize takes that whole mess of JSON style data that I showed you before and turns it into, well, this. This is the page definition itself, right? Then, well, dialog defs contains component selector. So it's split out like this. Panes, component list, dialog pane defs down here. So it takes every level, so to speak, and splits it out. Now there's a map of how it does that. And that map is in normalizing schema here. This is where that happens. The simple ones like data field schema or provider schema for that matter are basically just new schema with a name and identifying the attribute that contains the name of the damn thing. It doesn't have to be the name attribute. It doesn't have to be the name member of the object, but I've kept it that way for consistency's sake. If there is good reason to use another one, feel right free. It is not locked in stone at all. But this basically lays out a map of how a definition might get split apart. So if we're looking at a page definition, right, it'll take a page schema to normalize this from. We were looking at this one, right? Normalize, response, page schema. And what you'd then get from that is, if you look at page schema, it checks, okay, well, is there a tabs member? If there is, that's an array of tab schema, which is up here. Is there toolbars? That's an array of toolbar schema, and so on and so forth. Dialog is supposed to be just a single dialog definition. So that's sort of how you'd put that together. But it basically establishes sort of a tree of how to pick these things apart so that they get thrown into the state and are nice and regular in there and can be accessed easily. Now, then after that, it basically just has a list of entities that it has normalized out, and those are stored. So that's how we get to where we are now. In most cases, all you need to do in order to establish a new type of page, for example, is figure out how you want it defined. Preferably use parts that are already in use. Like if this is a page that has some tabs on it, give it a tabs member that contains definitions of those tabs. If it's got toolbars, well, there's something for that as well. If you do need to add a new one, the place to do it is in here. You add its name to this list. You may also want to add a schema for it in here and make sure that it's hooked in the right spot. But that's it. That's how you'd add a new definition part. And in our case, to build the component thing, we needed a dialog schema because we didn't have dialogues before. And we needed a dialog pane schema because, well, we didn't have them either. So, all right, we've gone that far. We've got all of this turned into, well, this. Nifty. how do we turn it back again? Because when we want to actually render our dialog, we want to know where everything is, right? To do that, we have the connect dialog here. There's a couple of comments in here, but, well. The things we want in order to render a dialog, right, is we want the definition of the dialog. We want any data to show the dialog, right? We want to know, okay, so what is the information we need to actually render this dialog? In this case, I think item groups is probably a bit misplaced. Either that or it needs to be generalized. Right now, the only dialog we're showing is the components palette. So it's all right. It works. But you probably want to generalize that for further use in future. So the next time you have a dialog, it won't need an item group to start with. And the only thing it needs in order to do its thing, in order to have its functionality, is the use provider action. That's the use provider thunk does everything that it needs in this case. So that's the only thing you have in the action list here. All right. So now we have a state that contains the data that we need, or at least it contains the data, the definitions that we need. It doesn't quite contain the data yet. For that, we'd need a reducer. We need to have something that handles dialog data, right? It's not always necessary. Sometimes you just need a place to store your shit. There is one of those. The provider's reducer is sort of a generalized store some data under a name reducer. It doesn't really do anything fantastically exciting about it. It just provides you with a place to stash your shit. But we need something a little more interesting. In principle, we really don't, as it turns out. But in future, you might be happy that the dialog state is not mixed in with all manner of other state data. So what we've got here is quite simple, as you can see. Reducer, it's only got a single action that it's interested in. And that action is also registered with the action locator, which means that we can call it from anywhere. If we can get to the action locator, and we always can, we can get a hold of this particular action without having to import from this file. We just need the action locator. So we also have the reducer, which just basically sets the data object under the dialog name in the state, and then motors on out of there. That's all it does. This is sort of the very simplest example of a reducer, and frankly, in most cases, if this is all your reducer does, don't build a new one, because you've already got this baby. That'll probably do what you need. But let's go ahead on the assumption that we will in future need far more complex data interactions for the dialogues. It's not an unreasonable assumption, so we go. All right, so now we have a state that contains our page definitions, and it contains the data that we're interested in. And we've also, let's just leap over the fact that we have created a thing that loads in our items that we want for showing in the palette. It, in fact, uses this one. We've got that. Okay, excellent. Back to our container component. We need to extract that in a way that we can use from the state. Okay, well, it looks at some selectors. Dialog data is simple enough that it almost doesn't make sense to have a selector. It's just sort of, okay, get the named field in the dialog data. But in a future situation, you might want to replace that with a selector. That could well be. So let's see here, right? We've got, let's say, the dialog selector. The current dialog def selector. Let's say that's the one we're interested in, right? We want to know how we get the actual definition collated back again. Now, this is... Ah, yes, I did actually refactor this one to be much more readable. This is sort of your standard selector in many ways, right? It has, you know, a bunch of things that it can extract from the state. That's great and all. It's not fantastically exciting. And then it has this one. It takes an awful lot of arguments from various parts of the state. And then it calls hydrate children. We haven't talked about that one, have we? Usually when you talk about hydrating a data object, it involves setting data on it. So you've got like a class of some kind, and then you're taking data that you got in like in JSON format or some other serialization, you fill it into the object. This does something similar. It takes a list of names of children, of names of a particular type, and replaces it with a list of objects fitting those names. So it's found in the utilities here along with the hydrate child. And basically what you have is it takes the parent object, it takes a list of the children that you should draw from, it takes a name of the member variable of the parent that it should hydrate, and then it takes optionally a function that it can call on each child after it has been hydrated, and that can then mutate the child, and it'll be part of the list. Hydrate child does pretty much the same thing, but in the singular. So basically, if you have a dialog instead of a list of tabs, you'd call that one. So now, hydrate children looks first at the dialog defs get. So it's getting a dialog definition. First it looks, okay, I have a page, right? The current page I'm looking at. Does that have a dialog on it? Yes, in this case. Okay, well, that's the dialog def we want. Either that or we want nothing at all because we're not actually looking at something that's loaded at this point. Okay, all right. So we've got our parent is the dialog definition. Then we want a list of the panes, the pane definition that we have. Okay, and we want to mutate the panes member of the dialog definition because that's sort of a list of the panes that we want to be able to show. And lastly, when we are processing each pane that we're looking at, we'd like to be able to change it before we return the result. So we throw in a function that does that. Here's where we do a minorly clever little thing, because instead of hydrating back into the providers list, we're looking at the elements. We have an elements thing, member, that contains two names of providers that we'd like. And so we grab that one. We say, okay, well, with the elements object in hand to hydrate the child fetch. So we call that function. That returns elements with that child hydrated. And then we hydrate the child update on that. And then we set all of that in elements on paindef. Okay, we're that far. We also need to hydrate the buttons, because same thing. All right, same structure. Paindef. Item defs contains the various buttons on this that we have stored in the system. Buttons, button def, and each of them we hydrate their provider. So now instead of this whole long list of unnested definitions, we have a single definition tree instead. So we have it neatly stored in a way that's easy to process with Redux, and we have it pulled back out in a way that's easy to process with React. Okay, great. Now we have it as a property object. We have all our data as a property object. We would like to actually show this on the screen now, thank you. All right, let's look at how we do that. Presentation. If you recall, looking at Connect Dialog, it puts the properties to the dialog element, component it's called, yes. So let's look at that one. We've got our imports and our styles and our whatnot. This is all very regular. Basically, these are all the primitives that you need to build your component from. Instead of using HTML tags, you use the styled components instead. And then we get to the actual meat of the matter. It's a function. It takes some properties. It pulls out the data and you know, operates on them. It transforms the list of button definitions that it got into a list of actual button elements. It sets up a function to be able to update its own data. And then it starts putting together what the actual rendering will be. So you've got a dialog box that has a search field. It has a little looking glass icon on that search field. That's all great. And then it shows a dialog pane. And then it uses a switch panel. Wait, switch panel. That was the one we used to determine what type of thing we were using for whatever. Right? It was what type of component we wanted to render for a particular thing. True. And if you look up here, pane types. It has a list of, well, currently there's only one possible type of pane, but you can imagine a number of others, probably have seen a number of others. Those you'd add here. Or you'd add it to a registry that replaces this. All right. So we're that far. That's great. That's excellent. So what it actually does now is we've got a bunch of properties. Sorry, got distracted for a moment there. What we've got now is we've got a whole bunch of properties flowing into a component that wants to render another component based on those properties. We can do that. This is completely acceptable. We've got the means to do that. And then we've got, like I said, the prop types definition here, right? So what we want to do now is the type that we actually want to render, the palette there. we need to feed the right properties into and make sure that it actually does what it says on the box. Okay, so let's look at that one. And it's much the same as before. It's not that different. You've got a bunch of styled components that you use as primitives to show whatever it is you're showing. You've got a few utility functions here that sort of help you do what you're doing. You know, if you want to toggle a group open or closed, then you can do it with this function, and so on and so forth, right? And then you have a function that renders all of that. And that's it. Yeah, that's probably a good idea. I think the big part that we need to cover at this point is tests. I mean, I think I've given you an overview of how to put together a new page and so forth. That'll do. So, looking at tests, right? Adding a test is as simple as adding a file inside of the suite directory here. The suite directory matches one for one the layout of the code. It should. So if you want to test the let's say this one, the providers reducer, right? You'll put the file there. You should probably keep the .spec.js convention, because then it's easy to tell if you've got the test file or the code file. And in there, well, you should always start writing the test before you start writing the code. That's how I've done all of this. It keeps you honest. It keeps your code testable. It saves you time. It saves your customers pain. It's always worth it. You're never too busy. You should always do it. There are no excuses.
What's the coverage you have with the tests in place now?
Currently, my test coverage is like so. It's not perfect. I will admit that. But
it's probably the most covered part of the entire system anyway, so it's good.
Yeah.
And I guess that the test is a great way to go look at also intent and just to figure out how stuff works and so on.
Yeah.
Did you do any night watch tests in any way? Not so much.
I did not.
Okay. If we were to take and like the approach we took with the night watch test that we have for the existing core, where we're trying to address it in a very labelish way, my guess is it would map reasonably okay to this setup. Not because of. Yeah. Okay, Ina, Tars, so yeah, it's been 2 hours straight, and it's tough, but it's actually been super good. I think even I learned something, even though I'm a little bit of a noob in this area.
I hope I wasn't too boring.
No, not at all. Ina, Tars, if any of you have any questions, which you're not sure you will be able to figure out by looking at the code, we always have
all the readmes. There's plenty of readmes in there as well.
Yeah. Then now is an excellent time to fire off questions. Yeah, go. Okay, Ina, go ahead.
No, I just can generate questions for now.
Okay, Tars, go ahead. Any questions?
How to add new presentation without recompiling C1, so in separated package. So
we don't have that yet.
Okay.
I mentioned the whole thing with the action locator as a prototype for other registries. specifically because I think that's probably the best direction to go in for using to integrate packages. I mean, it's not really something that's too useful before you end up starting to actually use the whole thing, as in use the full perspective view in the new system, because that's when you'll need to be able to hook things in pretty directly without just having it in an iframe. Until such time, you should be all right with just, coding it in whichever way and wiring it up to an iframe, like we did with featured products, I believe. That would work. But yeah, the registries, I think, are probably the way to go for making package functionality for the future case where the whole console is run in React and all of this in this code base.
So it's a to-do, but so this
It
is
very
this
much
is
is.
a work in progress also and now we've done a few views on it ourselves in the core, and we can see it working, so that actually makes sense, and then as we see things work, we start surfacing it, and this is how far we are, and it's still cool. Taz, any other
I really
questions?
wish I could have done more with it.
Not yet.
Not yet. Okay, but also, but this is cool. Also, I have a recording of this, so we will be able to get back to this. And again, there's the code is there. That's lots of tests, and we have running prototypes, and we're running code live.
Yeah.
So that should give us a good fighting chance moving forward. Thank you, Gert, very much.
Thank you for the chance to actually build this.
Yay. Cool.
Awesome.
Thank you, guys and gals.
Thank you.
Thank you.
Thank you.